All right, our whole unit of linear relationships really comes down to one thing. The relationship between y and x is summed up in the equation y equals mx plus b. In all of its forms, graph, table, situation, everything, the y and the x are connected through this relationship. With graphs, we've been talking about how m represents slope and b represents y-intercept. So in a graph, y equals slope times x plus the y-intercept. We've also talked about how the slope is the rise over the run, distance up and down compared to the distance back and forth. And the y-intercept is also where we start on the y-axis. Another way we've talked about slope is it's the ratio of the change in the y value over the change in the x value. And y-intercept, we've said it's where your graph crosses the y-axis or your line goes through the y-axis. Those are all different ways we've talked about this relationship using graphs. When we've been looking at the relationship in a table, we looked for the slope, or the m, as the pattern of change, and the y-intercept, or b, we looked in the table where our situation starts. That was one way we talked about it. We talked about in a table that the slope, or the m variable, represents the constant ratio in your table of the y compared to the x, that it had to be constant, had to be the same every time. And when we talked about where our table starts, what we really meant was where x equals 0. Remember, that isn't always the starting of our table. We had tables where our x value didn't start until 1. But when we say start, we mean when x is 0. And again, when we've been analyzing our tables, when we're looking for the constant ratio, remember we were just looking again for the change in the y value over the change in the x value. That was our constant ratio. And we're focusing on the point, the place in our table where the x value is 0. That's going to be our y-intercept. And again, in our situations or our story problems, the linear relationship y equals mx plus b, remember in a story we were focusing on the slope, or the m value, being the unit rate. And again, the y-intercept, or b value, was our starting point. In all of our story problems, we had some kind of end result, and that was related to how we calculate the end result. And that was always a relationship between where the unit rate was being multiplied by the number of units, and there was some kind of an additional amount. In our walkathon problems, the total collected was equal to our pledge rate, which was measured in dollars per kilometer, times the number of kilometers, plus our donation. So the pledge rate, that's our m value, and the donation was our y-intercept. In our story of Henry and Emile, the brothers who were having the walking race, remember the total distance was equal to their walking rate, measured in kilometers per second, there's their slope, times the number of seconds, that was your input, your independent variable, plus some kind of head start, that's the y-intercept. Remember when we were selling t-shirts, or going to order t-shirts for our walkathon, the total cost of the t-shirts was equal to the slope, or the unit price, in this case measured in dollars per shirt, times the number of shirts, plus the y-intercept, some kind of setup fee or delivery fee. And then we had examples of the buying CDs at the warehouse place versus the regular store, and we looked at our dependent variable, the total cost, which is the y, was equal to our unit price, our slope, in dollars per CD, times the number of CDs, our independent variable, our x, plus a membership fee of some kind. That was our y-intercept. All of our situations have been the same. Y equals mx plus b.